Hey everyone, and welcome to our lecture on understanding basic security. In this lecture, we're going to go over what are accounts. We're going to look at some account tools, and we'll talk about the root account and how we should work as root, when we should use it, and so on. So we'll start off with understanding accounts. So account features are specified in the etc passwd file. So this file contains one entry for each user account. And each entry looks something like this. So it's a bunch of fields, and each field is separated by a colon. Now, the meaning of these fields is specified down below. So the first field is username. Then we have a password, and this is kind of a holdover from way back when, where the password was actually stored in this etc password file, as you may imagine. However, this file has to be readable by any program. Anybody can read the etc password file. So it's not a good idea to have a password stored in here, or even password hashes, because hashes can be cracked. So to fix that, we have another file that holds the password, and that's the etc shadow file, which we'll look at here in a minute. So if there's an X here in the password column, which there should be nowadays, just know that the password for Rich is stored in the etc shadow file. Next, we have the numeric user ID. So each user has a mnemonic name, so something that's easy to read: Rich, Corey, Bob, Alice, whatever it may be. But each one of those maps back to a user ID, so an actual numeric user ID value. And we have the same thing for groups. So group ID here is 100. This would be for your primary group, and we'll get into groups here in a minute. Okay, next field is for a column. This is just a readable field that you can put whatever you want in here, maybe office location or phone number or something. In this one, they have the full name. So as they say, the comment normally holds the user's full name. And then the second to last field is the home directory. And we know that home directories normally exist under /home, and then a separate directory for each username. So notice that the username corresponds to the subdirectory used for the home directory for this user. Lastly is the default shell. So whenever you log in, what shell gets spawned so that you can use it. So if you think about when we log in with the VTs and we're at that command prompt, we're in a shell, and that shell that gets launched is the one specified at the end of the etc password entry. So bin bash is usually the one associated. Sometimes you'll see Z shell or some older shells in there as well. Okay, before we move into the shadow file, let's just go and look at the etc password file, see what it looks like. So I'm going to open up a terminal here, and I'm going to change directory to the etc directory. And if we do a listing, we can see that the password file is right here. So let's take a look at it. Let's do less passwd, and we can see all of the entries in here. So root should be the top entry for you. Its user ID is always 0, and its primary group is 0. Notice that root has a different home directory, and this is sort of the exception here for user accounts. Most user accounts, at least the ones that are intended to be used by actual people, will exist under /home. But root does not, and there's some reasons for that. The most important probably being that sometimes home is mounted as part of a separate disk. So if we had to do a minimal boot where we couldn't mount that disk, then we'd still want to be able to log in as root and have that root home directory. So we keep that under the primary disk /root. All right, there's a lot of different service accounts in here. So service accounts are these ones that they look like accounts, but they typically have either a bin faults or a user has been no login for their shell, and that just means you can't interactively log in as these users. Going down, I do believe I have my own account created, so let's get to the bottom here. There's bin faults, so again, this is an account that should not be logged in as. There we go. So here's an account that I created. One for myself, Corey, and we see that the password is in the SC shadow file, user ID and group ID, the comment field, my home directory, and my default shell. Okay, so every time we log in, this file is being looked at to figure out what groups to put you in, what shell to launch. Next, let's look at the Etsy shadow file. So the Etsy shadow file looks something like this. This is, again, it's a bunch of entries in the file, one for each user account, and this happens to be Rich's particular entry. Alright, so the first field is, again, the username. The second field is the password, which is salted and hashed. If you happen to see an asterisk or an exclamation mark, that just means that there's no password on that account. Alright, the last password change is the next field, followed by days until a change is allowed, so 5. Days before a change is required, 30. Days of warning before password expiration, 14. Let's see, days between expiration and deactivation, -1. That just means that it's disabled. Expiration date, -1. That's disabled. And then any special flags, which are usually just used by other programs, so we won't see those typically. Okay, so if we want to identify accounts, there's a few ways we could do that. We can use the grep command that we learned about. Grep is for searching. So if we grep, let's say my user name out of the Etsy password file, we'll find just my entry, so just the things that match my search string here of Corey. There is another program that we can use called getInt. So if we look at that, this gets entries from the name service switch libraries. And this can be more powerful sometimes than just looking at the Etsy password file, especially if we have our system configured to maybe get our login data from somewhere else, like an LDAP server or something like that. So for now though, it's actually just going to return the same thing because I have just a basic installation. I'm not using any centralized authentication. All authentication is done right here in the Etsy password and Etsy shadow file. So let's do getInt password, oh not Rich, let's do Corey. And we see we get that exact same line out of the Etsy password file. So additionally, I want to just show you that we can look at accounts via the system settings as well. And this process is typically the same throughout all the desktop environments. Some things will be located in different places, but usually it's a matter of going into the system settings and then finding something related to user accounts, like we see here, and we see there's my user account. Now if I wanted to, I could unlock this. So you have to unlock it because only the administrator is allowed to create accounts. We wouldn't want anybody just willy-nilly creating accounts here on the system. But I am an administrator, so I'll put my password in and let me create a new account. I have the option of creating a standard account or an administrator account. So I'm just going to make a standard account for Alice Smith, and we'll make her username Alice. Alright, so that created an account called Alice, and if I want to, we can see that right now the account's disabled, so I need to set a password for it. So I'm going to go ahead and set one. Okay, and it says that it's not good enough. Great, right? Let's try. I'll take that. Password 1. Cool. So now I've created that account. From here, we should be able to log in as Alice. So maybe we could try one of our VTs. If I switch over to VT1, I can try to log in as Alice and use that password that I just created. And now I can log in as Alice. We can see that if I look at where the working directory is, we're logged into Alice's home directory right now, /home/Alice. So I'll go ahead and exit to log out of Alice, and then I'll switch back over to the GUI. Great. Now, let's also understand what groups are. So groups are all stored in the etc group file. So it's a similar setup to the etc password etc shadow file in that each group gets its own entry in this file. So here's an example of the group users. We can optionally put a password on a group. I don't see this done usually, so typically I just see an X, but just know that you could put a password on a group. We have the group ID. Okay, so we saw that back in the etc password file right here, the group ID. So those match up to each other. And then we have a user list. So the list is a bunch of different usernames separated by commas, and those are the members of that group. So let's jump over into Ubuntu and see if we can't inspect the groups here. So let's use our less command and look at our group file. We can see a bunch of different groups. So typically, whenever we create an account, that account is going to get its own group. So we can see that root has its own group here. It has a group ID of 0. No members. And if we come all the way down here, we should see a group for myself, Corey, which has no members, of course, other than myself, right? Because I am a member of that group. And then we'll see some other groups in here that I'm a member of, like Samba Share, LP Admin, Plug Dev, sudo. So that's what gives me the ability to run the sudo command. If I wasn't in that group, I wouldn't be able to do so. CD-ROM. So a lot of these groups have a particular meaning. Plug Dev, I think that has to do with plugging in hardware. CD-ROM is obviously accessing the CD-ROM so that you can use it. The ADM group, so syslog and me are members of that. So it's pretty easy to come in here and inspect this, and this is actually what these GUI tools are inspecting as well. Whenever they show you in sort of a nice window what groups you're a part of and stuff, they're really just reading from this file. Alright, so how can we identify what group we're a part of? We can use the ID command. Let's jump back over and let's use the ID command real quick and just look at its output. So this is what the ID command gives us. The ID command shows me who I'm currently logged in as, my user ID. So the numeric user ID is 1000. That maps to the user account Corey. The group ID is 1000. This is known as my primary group. Okay, so the primary group is the one that comes from, let's do this get int one more time. The primary group is the one that's specified here in the etc password file. And then secondary groups are the ones that we saw in the etc group file where we had that member list. So you remember I wasn't in the member list for the Corey group, but I do appear to be a member, and that's because that's my primary group and is specified here in the etc password file. And then any secondary groups are all listed here in this groups equals separated by a comma. So we have the group ID, the numeric version, then the mnemonic what that maps to. So this is a great way that we can concisely see who I'm logged in as, what, GUID and UID, GID and UID, the numeric values are, and then any supplemental groups. Now, we may want to switch a primary group, and reason being that we may want to do that, let me jump back to my home directory and create a file called example.file. Okay, and if we do an ls-l, what we can see here is example file is this line right here, and we have the permission string, the number of references, the reference count, and we have the owner and the group. So we'll get into permissions a little bit later, but right now look at the owning group of this file is the Corey group, and that's my primary group. If we want to change our primary group, then we can use the new group command followed by a group that we're a member of, so maybe sudo. Now if I create another file, let's do example2.file, and let's do ls-l. Notice that by default, the sudo group now owns example2.file. Okay? So that's one way that we could easily change who our default group is, and that's not to say that I can't go back and change this one to sudo after it's created, and we'll learn about how to do that in an upcoming lecture. But for now, if we're working on a group with other students or other colleagues on the system, then we would probably want, and if we were all in the same group, we would probably want to go ahead and just switch our groups so that they have access to it as well. All right, so that's the whole point of this new group command. So discovering your own identity. As you're sitting on a box, maybe you've been logged in for a while and you can't remember who you logged in as. There's a few commands that we can use to figure that out. So we looked at ID, and we got to see that ID showed us all sorts of neat information about our UID, our GID, and the groups that we're a member of. There's some command line flags that we'll look at. -G will give us just the group ID. -GM will give us the group name. Okay. There's also this who am I command. I like this command because it's very easy to remember. You're logged into a box. Maybe it doesn't show you the shell prompt like this because it's easy for me to see I'm logged in as Corey. You just type in who am I, and it'll tell you who you're logged in as. So again, just to reiterate, -G will show me that, oh look, I changed my primary group and now it's showing as sudo. So it's showing that the primary group ID is 27, and if I want to get the name for it, I can use the N flag and see that that is sudo. So let me just switch this back here to Corey, and we'll see that that's now changed, and now it's group ID 1000, and Corey is the name. Awesome. So lots of other different options that we can use. I encourage you to get in there and just play with some of these. Try out the -U and throw an N on the N afterwards and see the difference between the numeric and the mnemonic name. If we want to know who else is logged onto the box, we can figure that out in a couple different ways. One way is with the who command. Let's jump over and let's use the who command, and we can see right now it's just me that's logged in. I'm logged in using TTY7, right? So Control Alt F7, the VT7 is where I'm logged in. Shows the date and the time that I logged in, as well as the display, the X11 display that I'm using is :0. Let's go back to TTY1 and log in as Alice again. So put in my password, and now I'm logged in. We can see who am I as Alice. And I'm not going to log out this time. I'm just going to switch back to VT7 and run who again. And now we see that Alice is also logged in here. So Alice is logged in on VT1 or TTY1 and is not using X11, so there's no graphical display, so we don't see that there, but we do see the login time. Great. So additionally, if there was people logged in remotely, like via SSH, which is the secure shell, it's a way that we can log in and get command line access securely and remotely, or perhaps via VNC or some other different protocol, we would also see them here in this list. So some sample output here, and I'm glad that they included this because this is an example of what you might see if somebody's logged in via SSH. We can see the IP address that they're logged in from, and they're on a pseudo terminal, so PTS/0 is where they're logged in at. So the who command also has different command line options. Let's jump over here and take a look at those in the man page. So one of the ones that they were using was who-q, and if we didn't know what that meant, we could come in here and look and see that that's all the login names and number of users logged in. So who-q shows me that Alice and Corey are logged in and there's 2 people logged in. Awesome. So again, another way to just pull out some information, get it nice and concise, and just see what we want. There's also this variant of the who command, so similar to the who am I command that we used previous, but this one is actually the who command with some command line argument. So it is different than who am I. So who space am I actually doesn't return anything. So maybe this isn't supported here. Not sure why it didn't return anything. All right. Additionally, there is the W command, and that is a little bit different than the who command. We can see it provides a tad bit more information. So we still get that TTY. We see where they're coming from here. So this could be something like an IP address if they're coming from SSH, or an X11 display, so :0 in this case, or maybe they're just logged in on the TTY and they're not using X11 or SSH. We won't see anything. We can see when they logged in, how long they've been idle. So apparently I suspend my VMs a lot, so I've apparently been logged in for 83 days here. We can see some stuff about CPU usage as well as what command they're running. So this upstart -- user, sort of like the init here for Ubuntu. So it shows that that's what I'm running, and Alice right now is just running bash. So I should be able to jump back over here and maybe run a ping command. So if we just want to ping google.com, we'll send it a package, it'll send us a packet back, and we can tell that it's up. And that's going to run until I press Control-C. So I'm going to let that run and jump back over here to VT7 and run the W command again. And we can see that Alice right now is running ping google.com. Okay, so it's possible for other users to see what commands you are running. So let me switch back over to VT1 and we'll do a Control-C. That stops the command, and Control-C is a good sequence to just remember. You know, if you're in a command line program and it freezes up, feel free to just press Control-C. Usually that'll break out for you. And while we're looking at the ping command, we can see that there are some statistics that come out down here at the bottom. This is a good way to figure out if we're getting any packet loss or anything between 2 different destinations, one being ourself and the other being who we're pinging. In this case, I have no packet loss, so everything looks really good. I'll switch back over to VT7, run W again, and we can see that now bash is the program that Alice is running. So ping is no longer running. Okay, so again, just some more sample output here from the W command. Lastly, let's talk about working as root. So we have this root user, and the root user is used to perform administrative tasks. So things like installing software, creating other user accounts, and sometimes we call this account the super user account. It could be spelled either way, or just root. In the Windows world, we know this as the administrator account. Now, there's other accounts as well, and those would be ones that we create. So, for instance, like the Corey account that I created, or Alice, those are other accounts, and they're known as unprivileged accounts or unprivileged users, sometimes called standard users. Now, we can take one of these other accounts and we can put them in the sudo group, like we saw that I was in, and that gives my account the ability to run commands using sudo in front of it. And just to recap, what sudo does is it allows me to run one command as root. And as we saw in a previous lecture, that also logs what you're doing into a log file so the administrator can easily go back and see who's running commands as root and what are they running. So that gives us some accountability as well. So we got regular user accounts, we got the administrator account, which is root, and then we also have system user accounts. So these are the ones we saw that have the no login for their shell or bin faults so that they can't log in. These are for daemon services or applications. So things that aren't meant to log in, but maybe they need file ownership or group ownership. By default, you'll see that these guys have a low UID number. They have no password, and their default shell is usually one of these guys indicating that they can't log in. So depending on your distribution, let's go back and let's look at this etc password file. The user ID for system accounts is usually either less than 500 on a Red Hat based distribution, or it's less than 1,000 on a Debian based distribution. So Ubuntu is a derivative of Debian, and we can see when I started creating regular accounts, so even though this may be sort of a privileged account because it's in the sudo group, it was created as a standard account. Its UID started at 1,000. And then when I created Alice, it picked up on the next UID, 1001. So if I created another account, it would pick up on that and it would become 1002 and so on. All right. So there's a few different ways that we can acquire root privilege. The way that I recommend, and the way I think most people recommend, is using that sudo command. Sudo is just nice because it allows you to get those things logged in a file, so there is accountability. And you also don't want to be logged in as root all the time because we could accidentally type something that would completely destroy our operating system. So logging in as root is very dangerous. In fact, some distributions make it to where we cannot log in as root. So if we come back over here, let me just look at the beginning or the head of this etc password file. We see that the root password is stored in the etc shadow file. So let me look at the head of etc shadow. Oh, and it says I can't open it for reading. I get permission denied. And that makes sense, right? Based on what I was saying earlier, all applications need to be able to read this etc password file, but we create this etc shadow file to store the passwords, and this is one that is restricted for access. So I am a sudo user. I'm going to put sudo head etc shadow. That's going to allow me to run this head etc shadow command as root. So if I do that, it's going to prompt me for my password so that it knows that it's me. And I can do that. And check this out. Remember back, what does the asterisk and the exclamation point mean again in the etc shadow file? That means that there is no password, right? So Debian-based distributions create a root account with no password, meaning the way that they intend for you to become root is to use the sudo command. Now we could get around that, and we could use sudo to log in as root. We could set a password on root, and then we could use the root account as if it was any other account. But this is just a safety feature that's built into Debian for us. Okay, so a couple different ways we could log in as root. I guess the first good example here is how I did this, where I just ran one command as root and it gave me access to read this file, whereas before I got permission denied. Another way is we could use the su command, and su is for switch user, change user ID or become the super user. Okay, so we could do su dash, and what the dash does is it just says run the startup files for that particular user, and it'll bring in environment variables and things like that that may be specific for the user that you're switching to. And if we don't specify a user name afterwards, it's going to try to turn into root. But root doesn't have a password associated with it, so it's not going to let me do that. But it would let the root user do it. So there's sort of a little trick here that we can do, and we can do sudo su dash. And since I already entered my password for sudo, it sort of caches that for a predetermined amount of time. I think it's 15 minutes, but I could be wrong. But I had entered my password here. And I guess just a quick mention, when I entered my password, you didn't see any asterisks or anything moving, and that's a security feature. It lets me enter my password without showing you how many characters are in it. So down here, look, I became root, and if I run who am I'm logged in as root. So we can see the information for the root account, and now I can do root things. One of the things that we may want to do is change our password, or in this case, actually create a password. So let me use the passwd command. The root user has permission to run passwd for any user. So passwd, if we look at the man page for it, takes some options followed by an optional login. So if I wanted to change the password for the Corey account, I could run passwd Corey. Or if I wanted to change it for Alice, I would run it like this. But if I want to change the password for my own account, I can run passwd with no other options. And it's going to ask me for a new password for this account. So I'll put one in. We see that it's updated successfully. Okay. Actually, let me put in a different password here. Cool. Alright. So we've done that. Let me exit out of this. So when we exit, we log out as that user, and I'm back as myself now. Who am I? I'm Corey now. Okay. Again, let's look at etc password. Still has an X here that is storing the password in the shadow file. And then let's do sudo head etc shadow. And now instead of an exclamation point, we see a salted and hashed password for root, which means now I should be able to use su dash, and it's prompting me for a password. Now it's not prompting me for my password, it's prompting me for root's password, and it should hash down to this right here. Okay, and I'm throwing this word hash around. What hash means is it's a special cryptographic function that we can take our clear text password, run it through it, and it maps it to a unique value on the other side, typically a numeric value or one that could be represented in maybe base 64 or something, so we get different characters in here as well. Now there can be hash collisions. There's different hash algorithms out there, but for the most part, this is a security feature because we can't work backwards. We can't take a hash and figure out what the clear text was. Now there's certain attacks that we can try. We can take all the known passwords in the world, or all the common ones, and we could hash them and then see if any of those hashes match the hash. But even that's not going to work here because this was also salted. Okay, so when we salt something, we take another unique value, we combine it with the password, and then we hash it. That stops pre-computed hash attacks, or also known as rainbow table attacks. All right, but I digress. I'm getting off on a tangent here, and what this is asking me for is the root password. So what is the root password? I just said it a minute ago. I hope I can remember it. Of course not. Let me try one more time here. One more time. Awesome. So now I'm logged in as root. That also allows me to come back to like a VT. So let me exit from Alice, and I can log in right here as the root user, and I don't have to go in as myself and then sudo root. Alright, but this is still dangerous because everything I'm doing is as root, and if I wanted to, I could delete the whole file system and it would have no problem doing so. It would say, alright, no problem, let me go out and delete these files, and we would be SOL at that point and have to basically reinstall the distribution. So let me exit out of there. Let's go back to our GUI VT here. So I highly recommend that we use sudo. There are a few different ways that we can use su. So this was the way that we could become root. This is the way that I could log in as Rich. So I guess just a quick example here. Let me exit out of root. So I'm logged in as Corey right now. If I wanted to, I could become Alice. And of course, it's going to ask me for Alice's password here. So password. I'm sorry, I'm not keeping all these passwords in my head very well. Let's do a sudo. So if you forget a password, the root user can always change the password. So I'm going to run a command as root, the passwd command, and we'll change Alice's password here. I'm going to change it to something that I can remember. Awesome. So now if I wanted to log in as Alice, I could use the su command and just type in her password. Now I'm logged in as Alice. Who am I? Who am I? Great. Additionally, we could also just run a single command as that user by using the -c command. At that point, though, you might as well just be using sudo, right? Okay. The graphical equivalent to sudo, when it prompts us for the password in the terminal, looks like this. So this is a pop-up similar to the UAC prompt that we get in Windows, where it's asking us if we'd like to continue. This one's asking us for the password so that we can run commands as the administrator, and we just click authenticate and it would go ahead and run that command for us. So wrapping up here, when we use root, we want to make sure, do we actually need root to do this command? If we don't, then let's just stay as an unprivileged user. And before we do anything as root, we should think about that, and we should go ahead and type out the command, but before we press enter, let's look at that command and think about any ramifications that might come from it, right? Because we know that rm-rf is going to recursively delete everything forcefully, and it's not going to ask us, are we sure? Okay, so that's something we want to keep in mind. Just take your hands off the keyboard, look at it, do we really want to run this? Never run a suspicious program as root. So there's lots of programs that we can download out there. When we download and run a program, whether it be a script or an executable, a binary file, we are essentially running that command in the context of ourselves, and whatever commands that particular program has, it's going to run as ourselves. So if we run a program as root, then we're essentially giving that program root access to our computer to do whatever it wants. So we want to make sure that we trust the program. That may involve inspecting the source code for a program, compiling it ourselves. If it's a script file, just opening it up and going through that script file and making sure nothing looks malicious in there. This is something that we can't always do though, right? That could be a very exhaustive task. So there's some programs that we can more than likely trust, okay? Ones that come from our distribution, that passwd command, we can probably trust that. So I guess there's different levels of paranoia, and if we wanted to, we could inspect the source code for everything, but we may never get anything done on the computer that way. So just keep that in mind. When you do use root, make sure you only use it for brief periods, especially if you're doing the sudo su or the su dash and you're logging in as root. Just do what you need to do as root and then log back out to your unprivileged user. Unprivileged users, by default, can't completely mess up the system, but root can. And then lastly, be careful with that root password, especially if you set one, like we did here in this example as we went through so that we could log in as root. If someone else gets your root password, then they can log in as root and do what they want. So we want to keep that secret. And that wraps up our lesson on basic security. As always, if you have any questions, please feel free to reach out to me. And I hope you guys enjoy the exercises and labs for this week. Thank you.